Hi, good morning, good afternoon, good evening. This is Mike from Unknown Tech, and welcome to the Architect Podcast. This is episode 24, I believe. And so I'm excited to talk today about something that was just released in Nutanix. And it's really the architectural blueprint around AI. And we're going to get in depth a little bit on that. I'm not going to go word for word and go through the actual blueprint and read through it. I'll leave it to you guys to actually do that. But essentially, what we're providing is basically this foundational blueprint where we're providing you a guide, so to speak, or it's not even a reference architecture. It's a blueprint, right? Because every system is going to be built differently according to your requirements. However, there are certain things that we can do to deliver a repeatable, right, underlining blueprint that you can apply to your design. Okay. And what I'm talking about is really how do I build my enterprise AI platform? Another term is enterprise AI factory or AI factory. And how do I do that in house? All right. How do I bring that on prem and give me that capability that I'm typically used to getting within a SaaS provider, a neo cloud, or a hyperscaler? Right. And because what we're seeing is this movement of AI workloads coming out of SaaS, out of neo cloud, out of hyperscaler, not all of it, but some of it that requires data sovereignty, data gravity, right? Ownership, governance, and control around that data, IP governance and control around your intellectual property. And also, how do I lower my cost, right, from a token economics perspective? And do I really need to use a frontier model that's going to charge me X per token, where I'm hitting limits or I'm reaching or exceeding, not just reaching anymore, it's exceeding what was budgeted, right, in the past. And so, Jensen from NVIDIA, you may have heard me say this before in past episodes, is why would you outsource your intelligence? And there are good reasons why you would do some of that, right? Obviously, the first reason is how do I start quickly? And I think that's where a lot of the customers I talk to in the enterprise have gone down that path of, it's going to take X to get for me to build this on prem, right? And so why don't I just leverage the hyperscalers or the SaaS providers? And what do you mean by SaaS providers? I'm talking about like Anthropic and OpenAI, et cetera, right? I can leverage those folks, including neoclouds for infrastructure as an example, and start quickly, right? Because, again, it goes back to what I talked about before. The plumbing is not really where the value is seen. The value is seen at the actual agent or AI application layer. Value is always seen at consumption. It's never seen at the back end. Okay. And so it's a hard sell to go back to the CIO to say, hey, we want to build this on prem. But what's happening, there's a few things that are happening. The first thing is traditional infrastructure teams are being pushed out of for this use case. They're not being brought into conversations for the most part. And what happens is they start seeing that they're starting to become irrelevant around these use cases, and they see that AI adoption's happening in the company, and they want to be a part of it. And what they're looking for is to say, you know what? We know shadow AI is happening. We know that there's exorbitant costs. We know that there's risk. And so we want to be the delivery mechanism of the back end for AI, for our enterprise AI workloads and agents. And so they're asking companies like Nutanix, as an example, to help them transition, right? Not fully transition, because this is going to be a transitionary period over time, but to transition and build a enterprise AI platform service. And that way they can go back to their customers, which is their internal users, to say, hey, we had this in-house. We can do this cheaper, smarter. You can maintain control. We can have control of our data. Shadow AI is a thing of the past, right? And even if you want to leverage external services outside of the enterprise, like a hyperscaler service like Bedrock or Vertex AI from GCP or Google Cloud Platform, or excuse me, Google Cloud, or a provider like Anthropic or OpenAI, we should still have visibility in doing that. You should still route through the services that we provide, and we'll talk about what that is here in a little bit, where you can get to those, still get to those services, but we still maintain visibility, control, right, around the service itself, the availability of the service, and the cost model, right? And that's something that enterprises are longing for. And again, I talk to enterprise every day, and they have contracts with hyperscalers, with SaaS providers, right? The feedback I'm seeing now is that, I heard one customer tell me the other day that with each iteration of model, right, at the SaaS frontier providers, their costs go up exponentially, 5 to 10x. And so, how do they control that? You can't, right? It's not, generally speaking, a typical model that enterprises are accustomed to, right? It's more of a, I want to, buy a contract, and within that contract, I'm going to get benefits depending on the length of the term, right? And that's not what's happening. What's happening is they're buying a contract in token limits and token utilization, and then yesterday's model, frontier model, was getting them X percentage, but value per dollar or per token. And now the new one's getting value per token, but it costs 5 to 10x more. How do you control the budget around that? And I hear not just from a technical standpoint, from the finance standpoint, it's troublesome. And so the reality is that's what's kind of driving the need to look at building your AI factory on-prem. And I'm not talking about, when we say AI factory, when Jensen talks about it, he's talking, he's pointing at NVL72 GB300s, right? Rack scale, water cooled, massive racks across the data center. That's what he's talking about, because his biggest customers are the hyperscalers, are the large, research facilities that are funded, are the SaaS frontier model SaaS providers, right? Are the neo cloud providers. That's who's eating up all of Jensen's capacity at NVIDIA, right? It's not so much the enterprise, right? It's not the commercial side of it. It's the provider side of it that's eating up all of that. And that requires rack scale solutions, right? Massive rack scale solutions. I'm not saying that enterprise doesn't require rack scale solutions. We have that today, right? What I'm talking about is, hyperscaler, gigawatt AI factory, right? Plants and AI factories, right? Generally speaking, enterprises won't need something like that. And I say generally speaking because there are some enterprises that will buy GB300 NVL72s, which is the most expensive AI platform on the planet, right? So when you look at that, right, what we're looking at is designing for use cases, for specific use cases for the general population. Okay, what I mean by that is, the design that we're incorporating today, and we're going to talk about today, the blueprint, is focused on scaled inference and agentic inference, right? But at a reasonable level, right? At a level that enterprises would probably engage in, and it's pretty scalable. Okay, you don't have to buy GB300 NVL72s to do your AI or provide your AI services. If you need that capacity, you're better off renting it from a neocloud, right? If you're training or doing something like that, you're better off doing that in the cloud, not on-prem, okay? Because of the cost. And so let's break this down a little bit before we get into the actual blueprint. And before I start, if you click the link below, you see here, I have a YouTube link at the bottom here. This typically provides a better quality experience than LinkedIn. So if you want to go over to LinkedIn or want to go over to YouTube channel, it's streaming to both LinkedIn events and YouTube. You can do that as well. So if you want to do that, just click that link or copy this link and paste it, and you'll be able to go to the YouTube channel. I use Restream, so there is a delay. So if you have questions, right, I won't see them for a little bit, right? I want to see what the delay is here. Yeah, it's a little bit off. It's about a minute or two from YouTube. So I won't see it right away. So don't think I'm ignoring you. I will try to get to your questions if you have questions. Okay. So let's start out by really focusing on, and let me just bring this down. The enterprise AI blueprint as we see it. Okay. Now, NVIDIA and Jensen talk about a 5-layer cake. I'm not going to talk about the 5-layer cake as they talk about it, okay? Because they include energy and all these things. I'm not including that, okay? So we're going to assume that what you're building for, you're going to have the required energy to actually build it. So let's draw this out really quick, okay? It really starts at the foundational infrastructure layer, right? And so when I come in here and I talk about infrastructure, what does that mean? Well, it means CPUs, memory, servers, GPUs, accelerated compute, what we call it, high, let's just say networking. And what I mean by network, I mean high bandwidth, high throughput networking. And I'm going to talk about the reasons behind that here in a minute and what I mean by high bandwidth, high throughput. I'm talking about bare metal and or a bare metal hypervisor. And what I mean by that is, I mean a hypervisor that can deliver very, very close, if not the same as bare metal performance, and why you'd want to leverage the hypervisor. And I'm going to talk about where we're going at Nutanix when it comes to that. It also includes the network switching, okay? And there are different network switching capabilities that you want to really focus on. And it's a little bit different than what you're used to today, okay? Because east-west traffic, right, when it comes to GPU to GPU, and I don't mean GPU internal in the node, I mean GPUs to other nodes. So say you have a cluster of servers, right? When I say node, I mean servers. When you have a cluster of servers or nodes that have GPUs in them, those GPUs sometimes need to communicate across the server boundary. And you need very, very robust, high-speed networking to deliver that. Okay. And then, of course, there's the storage component, which we'll talk about in a minute, that also requires you to feed those GPUs. And so you need low latency, high throughput storage access directly to the GPUs. We call that GPU direct. Okay. And we'll talk about that in a little bit. So this is what I'm talking about when it comes to infrastructure. And this infrastructure, I'm not talking about brands today, but I take that back. I will be focused more on NVIDIA because this first level design or first 1.0 design that we're delivering is in partnership with NVIDIA. And let's face it, NVIDIA has 80% of the GPU market. Let's just call it what it is, okay, when it comes to AI. And so probably 80+%. I may be off on that. But the reality is that's what's happening, right? NVIDIA is kind of owning that market today. And it's not just because the GPUs, I talked about this in the past, it's because the moat that they have is CUDA. Okay? The programmatic access that's been around for 15 plus years, that's robust, modern, capable, integrated, right? And where most of the programming knowledge is, right? It's in CUDA. And so that's the moat that NVIDIA has. Everybody thinks it's the silicon. The silicon's great. I'm not saying it's not, but CUDA is the moat for NVIDIA. All right. That's really what locks them in. Now, AMD has Instinct and they have what's called ROCm. So if you look at Instinct, that's their silicon, right? GPUs. And ROCm is their CUDA-like backend, right? Programmatic experience for, GPU programmability with applications. Okay. They're frameworks. ROCm is not as mature as CUDA, but it's becoming good enough. And so when we start looking at where AMD is going in the future here, I would say that AMD within the next year, you're going to start seeing them become a real player in the market, right? And it's a good thing. It's a good thing for consumers, right? And so what does that mean? It means that if I invest in NVIDIA today, does that push me out investing in AMD tomorrow? And the answer is it depends. It depends if you're fully invested in the complete NVIDIA stack. Because if you are, all the way to the inference engine like TensorRT LLM, I won't get into what that is, but we can talk about that in future episodes, then you will be locked into the NVIDIA stack. And that's one of the problems, right? We are doomed to repeat history once again in AI. Why would you build a platform that only is focused on NVIDIA? Why? You're doing the same thing you did in the past when you went all in on Oracle, all in on one hyperscaler, all in on Broadcom VMware, and you felt the pain. And so why do it again? You need a platform that can really access both. And we'll talk a little bit about that, but really we're focused on the NVIDIA Nutanix cooperative design today. Okay. So this is the infrastructure layer. Okay. The next layer that's extremely important is what I call the data services layer. Now, it's not the same, people always say, well, data services is not storage, and you're right, it's not. But I mix the two, right? So data services, this is your storage, unstructured data, structured data, data pipelines, right? KV cache offload. Like this is what I'm talking about when it comes to data services. It's the services plus the storage, right? It's your structured data, your unstructured data, your data pipelines, your KV cache offload, your application tier, persistent storage, if I can spell, right? It's all of those things, okay? And so I'll now talk about where Nutanix fits in all of these things in a minute, but I'm really kind of giving you this high level understanding of what the platform should look like. Okay, this is you're building your enterprise AI factory, right? This is what we're going through. Okay, and then the next tier here is extremely important as well. And the next tier is really what kind of orchestrates everything. Okay, and this next tier is the orchestration layer. And let's just call it orchestration. And that's really Kubernetes. Okay. That's really what's happening at the orchestration layer. It's happening in Kubernetes through operator frameworks, right? Through the Kubernetes scheduler. All of those things are happening. And those things interact. And this is what's funny, right? The orchestration layer interacts with all of this. Okay. Next is where you decide what AI platform services you're going to run. Okay. And in our case, we call this the AI platform services. So this is basically inference, endpoints, model, ops, gateway, agentic tooling, etc. And I want to just go back to the Kubernetes layer. So it's not just Kubernetes layer, but we can also deliver, in some cases, in the Kubernetes layer, it's not just the orchestration for AI, but also the orchestration for apps, your AI apps and your agents. I've seen this. I've seen people talk about, well, agents run in VMs. That's not true. Agents can run in any substrate, Docker containers, VMs, containers running within Kubernetes. I run Hermes on Kubernetes, right? Your agentic layer doesn't necessarily run in virtual machines, right? It can run anywhere. It's a application. It's a service, okay, connected to a brain. All it is an application of code, right? And without it connected to an LLM, it's not an agent, right? It's not. It's dumb, right? So the reality is you can run agents on any of those substrates. Now, what I will say is, again, it's apps, AI scheduling, orchestration, it's agents, MCP tools, etc. Okay, so it's running all of those things, and then your agentic tooling, governance. Let me go back up here. Security, etc. Okay, so basically, your AI platform services is what front ends all of this underneath. Okay, what I mean by that is your AI apps, and we'll build this here, right? Because this is 4-layer cake right here. Let's go to the 5th layer, right? The 5th layer will be your AI apps and your agents. Okay, I'm just going to move this. Let me just go back. I'm going to put this above. I'm going to put this above like this because I want to show the connectivity. All right, so we'll do this. We'll make this orange. AI apps, agents. Okay. I forgot to do in here, vector, TV, rag, okay, etc. Okay. So, from here, right, we connect our AI apps, right, into an agents, into the AI platform. Okay. And essentially the orchestration layer, right? Yeah, this tool is horrible. I hate this tool. Hang on one second here. Essentially, this is connected to everything. Okay. They're all interconnected. All right. And so now that now that you see what is required from a very high level, how do I now go and build this? Right. And infrastructure teams, they don't necessarily understand this area here. Let me just do this. They don't understand so much this layer and some of this layer, right? Like this. They don't understand this. They don't understand the requirements around these things, right? They're very good at storage, very good at, some are very good at Kubernetes when it comes to platform services. They're very good at the server infrastructure, the hypervisor, right? But they're not good at GPU scheduling. They don't understand GPU scheduling when it comes to inference. They may not be up to speed on high speed networking. I mean, very high speed with offload like technologies like SRIOV, et cetera. They may not understand all of that yet. And I have meetings with infrastructure teams all the time because generally speaking, that's most of who we talk to, infrastructure, platform engineers, right? And when we talk to these guys, they don't understand what they have to build. It's not just a bunch of servers with GPUs, right? And connected to some storage. That's virtualization. That's virtualization. That's offloading, VDI desktops, giving GPU offload to that. Completely different animal, right? That's what infrastructure teams are used to. They're not used to these other layers, okay? And let me just close this out. The reality is that that's where we need to help infrastructure teams. We need to stop saying that they've been relegated to the past. They have not. They still matter. And as a matter of fact, within AI factory foundations, they will matter more than you think. Okay? And so we have to arm the infrastructure folks to be ready to build the enterprise AI platforms of today and the future. And in order to do that, we have to help them and be consultative and have them understand why the things I mentioned within these, right? Like this, why this is important, why KV cache offload is important. What does it mean? Why, where do you play here? Okay. Why is this important? Why is the hypervisor, or choosing between bare metal and a bare metal hypervisor, right? We call it, you can also call it topology or hypervisor, right? Why is that important? What does InfiniBand look like, right? How does that new technology make sense? What does GPU to GPU look like within the server? Things like NVLink, right? Infrastructure teams aren't used to this today. I'm not saying they don't know what it is. Some don't. What I'm saying is they don't know how to architect and design around it. And so what we have to do is we have to deliver repeatable blueprints. And NVIDIA has done a great job at this. Okay, so let's get into what this looks like here. Oh, hang on one second. So at Nutanix, we have, when you log into the portal, right? You go to portalnutanix.com, you log in, or you don't log in, you'll have access to documentation. Okay. And you see, I'm not logged in. You're still going to have access to this documentation. So even if you don't log in and you can't, right, you can have software documentation. And what we're going to do is we can go back up to this hamburger menu, go to documentation, and we're going to scroll down to solution documentation. Now, Nutanix validated designs are different. Nutanix validated designs are real platforms that we deliver, right, that we test and we validate. So we do interoperability testing of software components, versioning, all of that. Solutions documentations are more like reference architecture and design blueprints. Okay, so you can see in here, we have a bunch. I'm going to go to the last updated ones and we'll talk about, we're actually going to focus on two today. We're going to focus on, oh, hang on, let me just get rid of this here. We're going to focus basically on these two things here. Okay. The NVIDIA certified enterprise storage, because this falls right into place with the Nutanix platform design blueprint for AI solutions. Okay. And this is focused on scalable units. Okay. And we'll talk about what that means, because NVIDIA basically outlines what a scalable unit is when it comes to scale. If you're just starting out and you're doing a pilot, right? These things aren't for you right now. Okay. What I'm talking about is you're now beyond the pilot phase. You know what use cases that you want to start with. You know the requirements, and those requirements dictate a platform that starts at a scalable unit, right? That has been defined by NVIDIA. And so within those scalable units, you now build out your production AI factory. Okay. And we call it the Nutanix platform for AI, but really you're building the NVIDIA AI platform on Nutanix. That's really what you're doing. Okay. The AI factory. And so this is not, again, for people that, you know what, we need a couple servers with some GPUs to start some inferencing. We have solutions for that. All right. We have designs. Okay. So if I go here and I go back to the hamburger menu and I go into the documentation under Nutanix validated designs, let's see what we have here. You're going to scroll down to the GPT in a box, right, with Kubernetes. Okay. That's a great starting point, right, for a small pilot, POC, et cetera. I would say pilot, right? But that doesn't mean you can't leverage our AI services, and I've talked about this before, if we go back to the whiteboard, that doesn't mean that you can't, leverage these AI services here, right, on your Kubernetes solution with your servers that have GPUs, right, with your data services, right? You still can do that. So some customers choose to say, you know what, I just really need this AI platform services. I already have the Kubernetes layer. I already have storage and data services. I already have the infrastructure. So I don't need any of this. And so we can layer on our AI platform services, we call Nutanix Enterprise AI, right on top of what you have today. Okay. And it could be on a server, it could be on a few servers, right? There's so many different ways of delivering this service. It could be in the cloud, right? So you have all these options. We're meeting you where you're at. But if you're ready to build an AI factory, an enterprise AI factory, then we can deliver a full stack capability. Okay. And that's what we're talking about today. All right. So let me just back out of this, go back to what I was talking about. And what we're doing is we're going to go into, again, documentation, solutions documentation. I do last updated because these were just released. And we're really going to focus on the certified storage, okay, and the platform blueprint for AI. So let's talk about that first. No, I have all these things open here. No, that's not it. Bear with me a second. That's not it either. Where the heck did they go? Here we go. Okay, so I downloaded this. It's approximately 54 pages. And again, I'm not going to go through the whole thing and read it word for word. You guys can actually do this, but I'm going to scroll through here and talk about what it is we're covering, right? So of course we provide this executive summary and we give you this, this Nutanix agentic AI solution. And it's really NVIDIA focused. You can see here all the green for NVIDIA, right? Because the design blueprint is really supporting the scalable unit model that NVIDIA provides. So NVIDIA has this model, right? And the model basically is, and let me just put this text box here over to the left here. Sorry. The model really is CPU, GPU, NIC, and NIC throughput, or bandwidth, I should say, speed. Okay. And so this is a scalable unit as designed by NVIDIA. So when I talk about things that the scalable unit is 2, 8, 5, 400, what I mean by that is the scalable unit includes 2 CPUs, 8 GPUs, 5 NICs, and 400 gigabits per second throughput. Okay, that's what I'm talking about. And NVIDIA defines these as scalable units to make it easier for you. So sometimes you have 2, 8, 9, right, 800, right, where you have 2 CPUs, 8 GPUs, 9 NICs, 800 gigabits of throughput, right? So this is what I'm talking about. And then we'll talk about some of the technologies, right? So the CPUs could be x86. They could be ARM, right? The GPUs could be PCIe or SXM based, which is basically, system on, silicon on chip or on a plane, right? So basically soldered right onto the plane, or you have a dedicated backplane or plane, mid plane, whatever you want to call it, right, for the GPUs. And then the NICs could be the NICs could be ConnectX 7, 8, and Bluefield and or Bluefield DPUs. Okay. And sometimes you have a mix of those things within a platform. Sometimes you have different models of Bluefield DPUs, and it's all Bluefield, right? Sometimes it's all ConnectX 7. I have 9 in here. It's really 8. Okay. But that's what I'm talking about, right? From a scalable unit perspective. And what we're going to be focused on is we're going to be focused on all of these things. Okay. Because we define these things within the blueprint. So at the end of the day, though, what we're trying to get to is we're trying to give you this, not trying, what we're providing you is we're providing you a full Nutanix agentic AI platform. Okay. And it's in partnership with NVIDIA, right? And so what we're doing here is, and it could be in partnership with others, by the way. I just want to make this point very clear. You're going to have a control plane and a consumption plane. The control plane could really be any vendor. It could be HPE, could be Supermicro, could be Dell, right? All of those things still apply, right? You still have some flexibility and choice there, even though we call out Supermicro and we call out specific platforms, right, that we support. So you could have other partnerships that you can plug into this design. And again, the idea is to provide model as a service, of course, supporting open weight models through Hugging Face, et cetera, and including NVIDIA NIM microservices, providing KV cache routing, OpenAI APIs, sandbox for VLM, speculative decoding, et cetera. And then we're providing a gateway layer that really provides you access to load balancing, failover, or routing to different model providers. Could be internal on this platform or multi-platform, or it could be external to your enterprise. Could be going to Anthropic, could be going to Amazon Bedrock, could be going to OpenAI, et cetera. You can leverage the AI gateway component to be the centralized point where all AI consumption happens. Okay. And that's very important because now you can provide broad foundation model support, have it routing internally to external, granular token based rate limiting. And you can, if you go back to some of the sessions or podcasts I've done in the past, I actually demo this load balancing, right, and failback routing. So if you have a problem or even internet outage that happens or something happens at the provider, you can fail back to either on-prem or another provider. We are providing a catalog for AI agents, right? We also provide an AI catalog for tooling services, things like Crew AI, N8N, right? Being able to deploy those and operationalize those, OpenShell, right? And then on top of that, we're providing natively MCP tool filtering, fine tuning, orchestration, evaluation, safety, right? And then from a data perspective, we're providing the infrastructure for your dev tools, your ML ops, and vector stores. And soon we'll be providing the actual data services, the AI services we call Data Hub, that will give you more capability around your data, bringing AI to your data, right? So imagine instead of requiring a data scientist and a developer to go in and write Python to curate your data, right? And I've done demos of that in the past too. It's very, very time consuming, right? You can use AI and natural language to actually build your pipelines. Okay. So a non data scientist could actually build the pipelines, and maybe the data scientist overlooks what you've built using the natural language, maybe makes some changes, and then integrates the data pipeline, right? And then, of course, with NVIDIA, we support all the NeMo framework, right? The NeMo evaluator, NeMo customizer, and NeMo services. To the left, right, we have the NVIDIA Kubernetes operators, the vGPU for compute. MIG is also supported. CPUs, GPUs, DPUs, right, and networking from NVIDIA, right? So, or others, right? CPUs could be NVIDIA, which are basically either Vera based, right, which is their ARM, Vera, or Grace, right? Grace is the previous generation. Vera is the new generation of CPUs. These are ARM-based CPUs from NVIDIA. GPUs, of course, can be PCIe-based, like RTX 6000 Pros, right, which I believe are the best bang for buck when it comes to PCIe-based inferencing, or SXMs, right, where you actually have NVL, H100s, H200 NVLs, right, that are SXM or PCIe based. and then DPUs like the NVIDIA Bluefield and networking switches like Spectrum-X networking from NVIDIA. Over to the right, we're providing the Kubernetes platform, the topology-aware hypervisor with security for DPUs, and the data infrastructure. What I mean by that is the data service infrastructure. We talked about that in layer 2, right? Which is really around storage, unstructured data, structured data, your data pipelines, et cetera. We're providing all of that for you. So I'm going to scroll down here. Again, I'm not going to read it. If you guys want to read this, you can certainly download it and read it. But basically, the support integration responsibilities, of course, with this blueprint, Nutanix will support all of our components, of course, and NVIDIA will support all of their components. Okay, and that's the model that we have. It's a shared responsibility model where we support, our components, NVIDIA supports theirs. And then, of course, the customer or designated system integrator support. What are they going to be supporting, right? Well, if you have a system integrator, which we would recommend, they could do end-to-end integration. They could do AI application development. They could do fine tuning. They can build your data pipelines, workload testing. I would recommend you have that partnership there, because I've seen where people start and they think it's a hardware exercise, and I'm just going to build this hardware and people are going to start consuming. No, there's the consumption to the right. So I always say there's 3 parts to AI. There's the back end platform infrastructure and platform and data services, et cetera. There's all the way to the right, the consumption layer, which are the AI applications, the agents, right? And this is generally where most people live. And in the middle, right, you have all the necessary things that have to happen: end-to-end integration, data pipelines, all of that. You really should bring in a partner for that to help with that, including AI application development, et cetera. And then, of course, we have assumptions. Remember, we talked about the NVIDIA scalable unit design. So we exclude 4 GPU configurations at the 243-200. It's not in scope for this solution because they target smaller deployments. And this is really to target someone who's ready for production inference at scale, okay? And in the enterprise, typically, okay? For smaller deployments, you can go to the NVIDIA GPT in a box solution. That's what I was talking about. That's the NVD, the Nutanix validated design for GPT in a box. The minimum scalable unit, right? Fundamental building block is a 4-node scalable unit. Okay, so imagine 4 nodes of the scalable unit: 285 or 289, 400 or 800, etc. 4 of those is a scalable unit. Okay, cluster management will be in the Nutanix AI platform architecture, 1 or more multiple Kubernetes platforms running AI workloads, and NKP clusters for large-scale environments that can configuration outside of the scope of the solution. So you can deploy additional Nutanix Kubernetes platform clusters, but that's out of scope for this blueprint. And what does the foundation look like, right? Well, we're providing you Nutanix Cloud Platform, which provides the management and orchestration layer for AI solutions, consolidating compute, storage, and networking operations. So Nutanix Cloud Platform is essentially Acropolis hypervisor, topology aware, layered on top of hyperconverged platform, right? That provides the compute, storage, and network operations. Then we provide Nutanix unified storage for your unstructured data services, right? That delivers high performance, scalable storage services, in our case, through Nutanix files and objects, and have been optimized for AI workloads. Okay, and we're going to talk about that in the storage section here in a little while. You have the Kubernetes platform, which manages the container workloads. They could be running on bare metal GPU nodes or running on AHV nodes. And then you have the enterprise AI layer, which is which we call NAI, Nutanix Enterprise AI, which offers a central model serving governance and lifecycle management for AI workloads to include the enterprise gateway. Prism Central is the unified management interface for monitoring and managing the AI solution stack. Now, what I mean by that, the infrastructure side of it, right? That's what Prism Central really is focused on. It's provide the unified management for the infrastructure side. Nutanix Container Storage Interface is really the CSI driver that enables dynamic provisioning and management of Nutanix storage, whether it's block storage or read-write many storage capability or cozy storage, right, for objects. In this generation, we're focused on NVIDIA Blackwell, even though it's it is the latest generation when it comes to PCIe-based solutions. Rubin has not delivered PCIe-based solutions yet, and Rubin is really right now only available in the NVL 72, as far as I know, from a GPU perspective. NVIDIA MGX platform is the modular server design, consists of entry-level PCIe-based GPU servers designed for smaller AI workloads, right? We integrate the NVIDIA GPU operator, of course. The NVIDIA network operator includes single root IO virtualization, remote direct memory access. Remember I talked about networking as a key component here. This all has to work together, okay? It all has to be a harmonious, right, delivery of integration of all the components in order to give you the outcome that you expect. And then, of course, we support the AI data platform, right, which offers predefined architectural patterns and best practices for AI solutions to include RAG pipelines, agentic applications, including vector databases, et cetera. So this we follow to the T to give you this predefined, right, architectural pattern for building data services. Technologies are SIOV, which isolate PCI resources, RDMA, NFS over RDMA, parallel NFS, and iSCSI extensions for RDMA ISER for network storage performance. All offloading, right? And we call SRIOV is really around single root IO virtualization. It's really around taking some, a NIC, right, network interface card, or a DPU, and kind of segmenting it up into virtual interfaces, as an example. So we also provide, the minimum software versions for all the components. I'm not going to get into this. You guys can read this, including the NVIDIA layer, right? The GPU operator, the network operator. I won't really get into this really quick, but I want to just stop here for a minute. So in this diagram, what we're showing you here is the top layer is the NCP, Nutanix Cloud Platform Management Cluster, right? And that management cluster basically houses three things, right? It houses the control plane for the infrastructure we call Nutanix Prism. It houses the Kubernetes platform management cluster, right? The control plane for Kubernetes. And it also houses the control plane for Nutanix Enterprise AI. And you can see here to the left, over here, we have unified storage. You can install unified storage in the management cluster. It's not recommended at scale. So we'd recommend you have a separate cluster, which is pointed at down here, for your unified storage. Okay, that's really what should be done, this dedicated files. Now, you can leverage this. One thing you could do is you could deploy NUS on this, right? And use these files, right, for consolidated mode where you're using it for things outside of the AI framework, right? Maybe you want to use it to store some things, unstructured data. It doesn't require a lot of high throughput, right? Low latency storage connectivity for unstructured data. Maybe you want to use this for your control plane, an observability stack, right? Storage as an example for your read-write many storage for the NKP management cluster, et cetera. You might want to do that here if you're adding specific features. But the recommendation is to really focus on a scale out dedicated Nutanix unified cluster here. You can see here to the left in dedicated mode. Okay. So that'll be a cluster in your data center, right? That's only running Nutanix unified storage for objects and for files and for volumes if you need it. Okay. So you have the ability to do block storage from this as well. To the right, you have your NVIDIA certified MGX or HGX nodes, okay, which contain the GPUs, okay? And what's happening here is these are your dedicated workload clusters for GPU inferencing here, all right? Up here, you have your NKP management cluster here. You have your NAI control plane, right? And you also may have workload clusters for your apps or your agents. Or it could be you're running Crew AI and that runs on Kubernetes, right? You deploy that, right? So you have the ability to deploy Kubernetes, additional Kubernetes instances for AI applications, apps, agents, tooling, etc. But the focus here is really around delivering high performance, right, in this layer here, okay? And so we'll focus a lot on that within this design. Okay, let's move on really quick here because I'm running out of time. This is going to be a longer one, probably 11:30. Scroll down. And again, it just goes through and talk about the topology, right? What's required for Prism Central, what's required for NKP management, right? 2 NKP managed workload clusters, right? What's required for unified storage. They have consolidated mode. Again, I wouldn't recommend that. I'd recommend dedicated mode. Nutanix Cloud Platform Management Cluster requirements. Okay, so I want to focus on these charts, but this is the management control plane, right? The management clusters, we call it, or control plane. Prism Central is your NCP control plane that gives you visibility into the infrastructure side as well as what your users are consuming, even with the Kubernetes layer, the storage, the networking, the nodes, the virtual machines, all of that. You have the NKP management cluster, right, which will run on that management cluster. And you'll have the NKP managed workload cluster for NAI that will also run on that management cluster. And so you have the NCP management cluster, and here are the resources required. So approximately you need this many VMs to deliver, right, the components. Prism Central is VM based. NKP will be Kubernetes based. So these VMs we're delivering to NKP and NAI are basically Kubernetes nodes. Okay, they're just virtualized. So it requires 17 VMs, approximately 166 vCPUs, half a terabyte of memory, and 2.5 terabytes of high capacity flash, fast flash. And the compute nodes, right, could be again, we look at compute nodes as they could be anything close to the 8170 G10 or 8150 G10 models, right? They could be, if you wanted to, they could be HPE, they could be Dell, they could be Lenovo, et cetera, right? But we're just building this on the Supermicro NX platform. What we like about the 8170 is a lot of power in a small footprint. It's 1U, one node, all right? So 1U, one rack unit with one node. The 8150 G10 is 2U, one node. Okay, so if you're concerned about rack space, right, and you don't require a ton of capacity, right, and you can see here I can get 64 cores, I can get 40 cores in the 1U, I can do 14 NVMEs, I can only do 8 in the 8170. So depends on what your requirements are, is what route you would go to, right? Now, another option too is you could, if you had rack space issues, you could do more 8170s, right, to add additional capacity. Right, it doesn't have to be 4 of them. Your add-on NICs and the PCI slots are RDMA enabled NICs, right, and they support Mellanox CX7 or CX6. Generally speaking, we want you to be in the Mellanox CX7. Dual port AOS storage network interfaces, dual port 10 gig base T. All right, and you have an IPMI, so out of band. Okay, so your onboard network connection is 1 gig. This is extremely important. Your out of band networking, extremely important. That's part of your design. And then your storage cluster, which is your dedicated NUS cluster. This is what we're talking about. The NUS dedicated storage cluster is basically giving you this configuration. Okay. And the throughput target is really 20 to 40 gigabytes per second per scalable unit. Okay. That's the goal. And we're supporting SRIOV network offload, iSCSI for RDMA, and NFS over RDMA. Now you're probably asking, what is this about? Why am I talking about iSCSI RDMA when really I'm focused on NFS? Well, the way Files works with Nutanix is it's a software layer that runs on our AOS layer, right? Which is basically we're providing what's called volume groups back to the file service VMs running on our platform. And those volume groups are basically block storage. So then they're iSCSI connected. So you want to do is you want to offload that connectivity, right? Offload that using RDMA because it's iSCSI based back to the file service VMs. And then we, through our software, we front end NFS over RDMA, okay, to the actual GPU nodes, right? So again, SRIOV is required. iSCSI extensions for RDMA give you offload for the file service VMs to our block storage, and then NFS over RDMA gives you offload for NFS, right? And we also use parallel NFS as well, okay? What we're looking at here in the file service VM configuration and controller VM configuration on these nodes in the file services cluster, the NUS cluster, is CVMs are using 32 cores, vCPUs, CVM memory, they want 256 gigabytes, file service VM CPU cores 32, and file service VM memory 512 gigabytes. Okay. And here's the file services storage AI performance profile, right? You can use 8150 G9s or G10s. Of course, we always want you to get to the latest G10s. But again, obviously due to shortages, limitations, right, availability, you may have to go to G9 or go with a different OEM, right, that gives you the same internals, right, from a flexibility perspective. Each one of these, right, we're looking at 16 NVMe. You have two tiers, right? You have a performance tier 4 and an NVMe tier 16. We're looking at RDMA-enabled networking, ConnectX-7, 200 gig. And then, of course, your management network and your onboard IPMI. And we're going to get into this here in a minute if I have time. If not, we'll leave the file storage performance profile for AI workloads for the next section. The Nutanix AI workloads, we're looking at here using NVIDIA certified scale-out bare metal GPU nodes for compute, okay? And all AI compute nodes are NVIDIA certified systems that have been tested for performance reliability with a complete NVIDIA software stack and Spectrum X Ethernet networking. Now, the question you're probably going to add is, can I substitute, Cisco networking into this? The answer is you probably could, but this is really designed to give you a blueprint around the Spectrum X Ethernet networking stack. And it's certified. This certification helps AI compute nodes form reliable building blocks for scaling AI factories. Again, here are the NVIDIA PCIe optimized reference configurations, right? You have the RTX Pro 6000, the H200 NVL, and the NVIDIA certified system sections, right? And that's what we're kind of building around. Right? I talked about the CPU, GPU, NIC, and throughput model that the NVIDIA optimized reference configurations align to. Remember that the first number is how many CPUs, the second number is how many GPUs, the third number is how many NICs, and the last number is the NIC throughput, the bandwidth. These configurations typically use PCI optimized systems such as RTX Pro 6000s with up to 8 GPUs and 5 network adapters per node. This is ideal for entry-level production deployments, including retrieval augmented generation pipelines, small-scale model training, and departmental inference systems, okay? So, again, we're giving you this building block for this design is for entry-level production deployments. And here's the design here, right? You have your scalable units, SU they call it, the SUs, scalable units, can scale from 4 to 16, and we do this in 4 scalable unit increments. All right, so we're not just adding a single node, we're adding a additional 4 scalable unit increment. Now you have 2 MGX PCIe optimized, 285-200, or the HGX SXM optimized, 289-400 or 800. Okay. And this design here can get you from 16 nodes with 128 GPUs to 64 nodes, 512 GPUs. Remember that you have to account for north-south network traffic. North-south network traffic is really around management traffic as well as storage traffic. East-west traffic is GPU node to node, right? Cluster to cluster eventually, but let's just say node to node within the cluster, east-west GPU traffic. And you can see here what we require as far as scalable units, nodes, GPUs, right? Number of leaf switches, available ports, number of NUS nodes with 3 CX7s, and total of CX7s needed per scalable unit. So what we're saying here is if you start with a scalable unit of 4, you're going to get 16 nodes, 128 GPUs. This is how many ports you're going to need. And this is the total amount of NUS nodes to support that scalable unit. And we're going to talk about how this scales here in a little bit. We use the NVIDIA Enterprise Reference Architecture documentation for these use cases. It's extremely important. Your compute node east-west Ethernet networking is done over RDMA, over Converged Ethernet, to facilitate GPU direct RDMA, which enables direct memory transfers between GPU nodes without involving CPU, right? So the idea here is GPU direct RDMA, GPU to GPU without involving the CPU, okay? The north-south traffic is converged. This fabric handles traffic including end-user application traffic, high-performance storage, I/O, Kubernetes control plane communication, external ingress by using NVIDIA ConnectX or Bluefield 3 DPU NICs. The architecture offloads packet parsing, storage management, security. Now, it could, again, I go back to what I said before. It could be a combination of ConnectX and Bluefield in a single node. It could be all ConnectX or it could be all Bluefield, but different models of Bluefield. Okay. And then you have your out-of-band management ports. Okay. For north-south traffic, it's recommended you have to configure link aggregate LACP. Implementing LACP aligns with HV deployment best practices. Do I have a question here? No question. Okay. So here's what the networking looks like. Okay, here's what kind of the design here. So let's make this a little bit smaller so you can see it. No, I hate to do that, but essentially what you have here is you have a dedicated north-south leaf spine switches here. You have the out-of-band management switch. You have your Nutanix Cloud Platform cluster. Okay, that's these 4 nodes here. You have your dedicated Nutanix Unified Storage NUS cluster. That's these 4 nodes here. So let's talk about that. Here's your management cluster here. Here's your dedicated Nutanix Unified Storage cluster. Remember I said to go dedicated. Okay. This is your north-south connectivity. Okay. And as I scroll down, let me scroll down here. Now I have my, let me just get rid of this thing. Now I have my AI workload clusters here, and they're in scalable units of 4. So in this case, I have 16. So I have 1 scalable unit here, 1 scalable unit here. You get the drift, okay? Now, this is your dedicated east-west between your scalable units and your nodes within a scalable unit, okay? You have to have connectivity between GPUs within a node and GPUs external to the node, okay? So within the node, they use NVLink. external to node, you'll use, generally speaking, you'll use Bluefield in these use cases, or ConnectX-7 or 8. Okay, and so you have your north-south traffic and your east-west traffic. Your north-south traffic handles applications, traffic, management traffic, and storage traffic from these nodes here. Okay, and then you have your east-west traffic, which should never traverse this switch here, this this leaf spine switch here. They should always traverse here. Okay. Let's go down here. I'm almost done here. I just want to talk about what this looks like from an internal to a node perspective, especially around file services. Okay. So we talked about a little bit about this. If you're not familiar with Nutanix's storage architecture, this is kind of a little primer about this, but essentially what we're doing here is we have what's called a controller VM for every node. This controller VM, right, is basically your storage controller. Okay. Don't worry about what Stargate is, but just really quick, Stargate is what provides the actual interface into the storage. Okay. And what we're doing here is we're leveraging iSCSI over RDMA. Extremely important. This is offloaded onto a NIC here, and this NIC handles the AOS RDMA storage. This is all internal. Okay. So we're offloading the connectivity from the file service VM to the block storage on the Nutanix node. When we deliver the block storage to the Nutanix or to the file service VM now front ends a protocol, right, to deliver back to the network using SRIOV, FastPath, out your NICs. Okay. And this is your client access into your files, into NFS, parallel NFS. Okay. Now it can do SMB, right? We know that, but we're not using SMB in this design. We're really using and focused on NFS. Okay. But essentially, this is what is happening. You have your AOS management network, you have your AOS block storage network and offload to the file services VM. File service VM then provides the protocol, delivers it back through using SRIOV and functions, right, through this NIC or through these NICs as an example. And now you have your client access for data services here. I hope that gives you kind of a quick primer on how we do storage for our unstructured data. Okay. Let me just scroll down here. I think we're almost done. So this is what single node connections look like, right? From a single node filer or NUS node, this is what this would look like. Okay, the connectivity. So what we're doing here is we're really delivering a very fast connectivity into the storage layer. And at the consumption layer, let's talk about this really quick. We're providing you enterprise AI, right? So here, right, we're giving you enterprise AI, access to Hugging Face, NVIDIA NIM, or your own models. We're delivering endpoints, okay? And then we're providing that endpoint with API keys back to your agents or your API, your AI applications. So at a very high level, that's what endpoint delivery does for, and model operations do for this platform at Nutanix Enterprise AI. It does much more than that, though. Okay, I talked about the gateway. I talked about agentic control and governance, token optimization, all of that. Okay, so this is the platform design for the observability stack. Okay, so let's just talk about the observability stack for a minute and the control stack. So this section, it provides production grade Kubernetes. Okay, So extremely important that you're getting all of the identity management here. Okay, all of the observability. So with Dex, you're getting identity management. Grafana, you're getting multi-cluster metrics. Okay, and you're able to do this within what we call workspaces. Okay, so you can actually segment your clusters out in workspaces, right? And you can say, okay, this Gen AI stack, this is NKP with GPU node pools. I have my observability stack here using the GLP stack, or GLK stack, excuse me, Prometheus, Grafana, Loki. Well, I can even talk, it's PLG stack is what I meant. You have your backup solution, right? And other components like Valero. And then we provide, use these open source tools, right? To actually deliver the inference, right? The GPU operator for GPU scheduling, Envoy for the gateway and the endpoints, Knative for the servicing, right? The inference services. And then, of course, we enable this through storage, through CSI, and then we provide NAI endpoints, okay? And so what we're doing here, and then you can add additional NKP AI workload clusters, and they'll still get the same AI workload stack, et cetera. However, this will be managed, right? Because people are like, well, look at this, and each workload cluster has its own observability stack. The answer is you're right, but you can centralize this into a centralized logging and observability stack, like a Victoria Metrics and Victoria Logs as an example. Okay. We talk about security a little bit, and here are the design blueprints. Okay, so here are the blueprint designs here. This is what it looks like from a rack perspective. So you have essentially, this is the 285-200. Remember, the scalable unit is 4 scalable units. Okay, so in this stack, what you're having is 285-200. So basically, each node will have 2 CPUs, 8 GPUs, 5 NICs, 200 gigabytes of gigabits of throughput. Okay. The 2 switches you'll have is you're going to have your NVIDIA SN 2201 out of band management switch. You're going to have your converged SN 55610 as your north, south, and east, west network spine leaf. And then you're going to have your converge NCP NUS cluster here. So this right here is a converged stack of NUS and NCP. Again, this is for entry level, but if you're going to do real scaling with this, you're going to want to have a separate NUS cluster. So in here, we have 4 NX 8150 G10s, NUS dedicated nodes. Then you have your compute nodes down here. These are basically your GPU compute nodes, and they're in 4 scalable units. In this case, we're showing you Cisco UCS C845s, M8 Rack, MGX with RTX Pro 6000s. Okay, this doesn't have to be Cisco; it could be something else, like I said. And this is your 4 scalable unit on that config. And then as you scale out, you scale out in these 4 scalable unit increments, right, up to 64 total nodes, or 512. Is it 512 GPUs, I believe? Okay. And that's the 285-200 with 4 scalable unit config. Here's one for the dedicated. Remember I talked about dedicated NUS? The other one was more of a consolidated NUS. This has dedicated NCP, dedicated NUS for your storage services, and then your scalable units. Okay. Here's the max config, right? So this config gets you to 32 nodes. I'm sorry. Bear with me a minute. This is the MGX PCE optimized 285-200, max 8 scalable units, 32 nodes with 256, scale out with isolated NFS, north, south, east, west, 4 NCP management, 5 NUS dedicated nodes. So you can see here we're adding nodes as we add more scale to this. Because remember, the more nodes we add here in NUS, right, the more storage throughput I can deliver. And I'll show you that. And we're not going to have time today to review that, but in the next podcast, I'm going to review the NUS, the storage design for AI. We'll review that. Okay, so that covers basically the Nutanix design blueprint, platform design blueprint for AI solutions. And it really focuses and encompasses on these layers here, not so much the AI apps layer so much, but really this whole stack here. Okay. So all of the infrastructure, all of the networking, all the units, right? The scalable unit design, all of that. I didn't get into the software so much. I just want to show you what the design blueprint foundation you can build your AI factory on, how you could do that with the NVIDIA Nutanix design that we have. So I hope today was relevant as you look at enterprise AI use cases and you look at building out your own AI factories, right? I'm sure a lot of you are looking at that. Really, I want to focus this more towards infrastructure and platform teams. And the reason why is because we need to educate these folks to get them to understand how to build a lot of these things, what's important, right? And the reasons why behind it, right? Why do we make these design decisions? Why do we separate east-west traffic, right, for GPU to GPU? Why do we have separate networking for northwest traffic? Why do we scale, storage with the scalable units with GPUs? Why do we do a repeatable stack like NVIDIA design, right? Because you're going to get a repeatable outcome, and we're going to de-risk the process. That's the whole idea of this, right? And then eventually we're going to have an NVD around, right, this solution, which actually validates this completely from a software perspective, a scale perspective, et cetera. And so when we do the NVD around that, it's going to say, okay, not only do you have this reference design that we know works, is repeatable, but we validated it and tested it at scale. And so that's what you want to see, right? So again, I hope you had this was informative for you as you go through looking at building out your infrastructure and your AI platforms. I didn't get into detail on each one of these components. If you want me to do that, just let me know. I can do that. But next week, what I'm going to focus on is the storage design around NUS and the reasons, some of the thought process around that. And I'm also going to cover topology aware Acropolis hypervisor. I think that's important to kind of focus on and talk about as we release that into the wild. And we're going to show you exactly the benefits of using a topology aware hypervisor versus Kubernetes running on bare metal. So I hope you have a great rest of the weekend, a very productive week ahead, and I look forward to talking to you soon. All right, have a good one.
Hey. Broke down bones, dust in the air. Eyes to the ground, no one cares. Empty streets, whispers bite. Lost my way in the dead of night. Hey. Rock bottom, yeah, I felt the crack. Hey. Time to rise, time to fight back. Hey. Climbing up, no chains, no lie. Gonna find my way back to the top. To the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Hey. Rock bottom, yeah, I felt the crack. Hey. Time to rise, time to fight back. Hey. Climbing up, no chains, no lie. Gonna find my way back to the top. but they don't own me. I've burned before, now I'm free. Fire in my veins, ashes in the wind. I lose, I learn, I begin again. Rock bottom, hit it, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no change, no lock. Gonna find my way back to the top.